जो वो है, उसने
शेयर वीडियो। हेलो रावत, आवाज आ रही है?
नहीं।
तेरी आवाज नहीं आ रही।
अब आ रही है।
अब
हाँ, आप आस्ते आ रही है बहुत।
अच्छा ठीक है, आप अपना कैमरा जरा ठीक करो।
आवाज नहीं आ रही बहुत, सुनो।
एक मिनट, वो क्या बोलते हैं, आएगी मतलब
कैमरा लगाओ जरा। आप
है?
फोकस करो कैमरा।
ये तो ऑन ही है।
कैमरा आ गया
आपका चेहरा पूरा नहीं दिख रहा, माथा माथा दिख रहा है।
है?
आपका फोर हेड दिख रहा है।
एक
कैमरा।
मिनट, एक मिनट, यहाँ से मैं देख रही हूँ।
कैमरे को जरा फोकस करो।
ये तो सब ठीक है इसमें। ऑडियो यहाँ कर दो, और तेज करना है।
हम्म।
अब तो ठीक है, पूरे कर दिए।
तो मेरी फोटो भी आनी चाहिए ना इधर।
आवाज आ रही है बम्बानी साहब?
हाँ,
ठीक
मेरी
है।
आ रही है।
आपकी बहुत बढ़िया बुलंद आवाज है। आप अपना कैमरा जरा नीचे करो।
कैमरा क्या करूं?
हाँ, नीचे करो। झुकाओ।
नीचे।
एक मिनट, कर रही हूँ।
नहीं, ऊपर गया, पंखा दिखाई दे रहा है। हाँ हाँ। और थोड़ा और। हाँ, अब ठीक है। ठीक है, अब फेस दिख रहा है आपका।
फेस दिख रहा है।
बिल्कुल बिल्कुल।
इसमें पता नहीं क्यों नहीं आ रहा। यहाँ आएगा, नहीं आ रहा।
मेरी फोटो आ रही है।
बिल्कुल आ रही है।
इसमें
यहाँ नहीं दिखाई दे रही
वो तो आप अपने देखो जरा, सेटिंग व्यू व्यू देखो, ठीक करो व्यू।
है।
अपने स्क्रीन में व्यू करके एक होता है ना।
कहाँ है वो? अच्छा ये। व्यू तो कर रही हूँ मैं,
व्यू
ये
लेकिन
तो
में
वहां का आ रहा है ना, मेरा नहीं जा रहा है ना।
वही देख रही हूँ कैसे आना तो चाहिए।
आपका दिख रहा है बम्बानी साहब?
दिख रहा है।
हाँ बिल्कुल दिख रहा है।
मेरे मेरे कंप्यूटर में नहीं दिख रहा।
वो आप व्यू करके एक है, राइट हैंड साइड पे टॉप की
भी कर
तरफ।
रही हूँ मैं, व्यू करके ही कर रही हूँ, नहीं आ रहा। किस में करना है वो, स्पीकर, गैलरी?
हाँ हाँ, गैलरी में कर दीजिए तो सारा चीज दिखाई देगी। अगर स्पीकर में दिखाओगे तो जो बोलेगा उसकी दिखाई देगी, बाकी सब।
नहीं आ रहा गैलरी में भी।
गैलरी में आ नहीं रहा।
पर कुछ और होगा आपका।
ठीक
हम्म।
है।
एक मिनट है, जा फिर। हेलो हेलो। आ गया आवाज, आ गई आवाज।
हाँ बिल्कुल ठीक है। वीडियो ऑडियो दोनों ठीक है। ठीक है, कल की पार्टी ठीक थी?
है जी।
कल की पार्टी ठीक थी?
हाँ, कल की पार्टी ठीक थी। हेलो हेलो।
हाँ जी हाँ जी। आवाज सुनाई दे रही है।
अभी क्या टाइम हुआ है?
अभी तो 10:36 हो रहे हैं, 10:35।
बहुत जल्दी खोल लिया।
हाँ वो भी चला के सो जाता है ना।
कहाँ चले गए? हाँ जी।
हाँ वीडियो।
आवाज ठीक है?
हाँ आवाज ठीक है, बढ़िया आपकी।
तुम्हारी आवाज जरा।
आवाज ठीक है हमारी भी।
हाँ।
वो तो माइक है ना, इसको जरा घुमाना पड़ता है इधर उधर। हाँ जी, आ गए।
थर्ड फ्लोर में कहाँ पर है? थर्ड फ्लोर में
और
हो गया मैं।
डायरेक्शन तो लिखी हुई है लेफ्ट।
लेफ्ट नहीं, तुम्हारा नंबर कहाँ लिखा हुआ यार?
यार सीधा सामने हर जगह हमारा नाम है।
अच्छा आ गया हाँ। इंडियन एनर्जी कॉन्टैक्ट में होता है सबसे ऊपर अलग से
हाँ।
लगा होगा तुमने। लेफ्ट पे आने के बाद
फिर देखो हमारा आया।
ऊपर रख दिया।
हाँ घुस जाओ अंदर, लेफ्ट लेफ्ट हो जाओ। आ जाओ अंदर।
हाँ जी।
महाजन आ
ऑलरेडी।
गया।
हाँ आ
महाजन
गया।
गुड मॉर्निंग।
गुड मॉर्निंग, गुड मॉर्निंग।
तबीयत कैसी है अब?
यार पता नहीं, ऐसी यार नॉर्मल नहीं हो पा रही। काफी वीकनेस पीछा नहीं छोड़ रही। पता नहीं वायरल के क्या क्या स्ट्रेन आ गए हैं।
तुमने यार उल्टा कर दिया ना।
क्या उल्टा
वेलकम।
कर दिया है?
वेलकम मुझे करना चाहिए था। रिपोर्ट ऑफ थैंक्स आपको करना चाहिए था।
कोई बात नहीं, अगली बार ऐसे कर ले। यही फॉर्मेट चल रहा है मेरे ख्याल तो।
नहीं ये फॉर्मेट नहीं चल रहा ना।
हम्म।
अभी भी चेंज कर दे यार।
अब नहीं कर सकते, अब अगली बार करेंगे। आप तो रहोगे यार, आप
मेरी भी तबीयत ठीक नहीं है, जरा मैं सोना चाहता हूँ।
हो जाओ, उठा देंगे आपको वोट ऑफ थैंक्स के टाइम। अभी तो है 15 मिनट।
हेलो हेलो इतनी देर में मुश्किल आ रहा है
छायो न कुछ बि करे नथा चाहियो एॾी ॿेर मुश्किल आहे सॼो ॾींहुं सुम्हणु मुश्किल आहे सॼो ॾींहुं करणु मुश्किल आहे बी हैप्पी न सॼो ॾींहुं हीअं पिया हूंदा त पाण वधीक ई बीमार थियासीं केॾा सुठा ठाहूका पिया था लॻूं तव्हां खां न कुझु बि कमु नथो मिले ईअं न कयो करिणो आहे आपने बिना नहीं पहले
नहीं
बम्बानी जी
हाँ जी
आपका आपका माइक म्यूट कर सकते हैं प्लीज
माइक म्यूट आवाज नहीं आ रही
आ रही है लेकिन आप अभी म्यूट में रखिए अभी
अभी तो म्यूट में है ना
नहीं है तो इसलिए आपका
अनम्यूट अनम्यूट में है अनम्यूट में है
प्लीज म्यूट इट
म्यूट कैसे करूं
उसमें एक माइक का सिंबल आएगा देखिए नीचे म्यूट करके
एक बोलने वाला सिंबल है नीचे
सो गया
आप पहले तो उसको मेरे पास सुनाई दिया
आपने जैसे बोला था ठीक हो रहा है जैसा आपने देखे थे रिकॉर्डिंग रिकॉर्डिंग में नहीं आया कभी भी
सोनिया
इट्स ओके ठीक तो है
इट्स नॉट इट म्यूटेड
है
इट इज स्टिल नॉट इट म्यूटेड जस्ट वहां पे म्यूट करके एक सिंबल है जस्ट ट्राई क्लिकिंग ऑन दैट
हमने बोला
म्यूट में क्या है म्यूट
अच्छा वो करना अनम्यूट
वो वो ब्लर में था किसी में नहीं
हाँ
आया
नाउ इट इज फाइन मामा नाउ इट इज म्यूटेड थैंक यू
आपको पता होना चाहिए कि वहाँ का है और मैं कर रहा हूँ जुबान भी कर
हाँ
एटलीस्ट ये काम की गलती वो कि मैं कर और दूसरा क्वालिटी आप मैनेज करोगे मैं तो बना रहा हूँ ना वो तो दे नहीं
अब ठीक है
तो या तो वो
म्यूट कर दिया मैंने
तो आपकी आवाज ही नहीं जाएगी ना
हेलो
हाँ वापस अनम्यूट हो गया जी आपका आवाज
हाँ मैंने अनम्यूट कर दिया
हाँ ठीक है आप वापस म्यूट करके रख लीजिए जब आप बात करना है तब ओनली यू अनम्यूट प्लीज हाँ दैट इज गुड गुड गुड
मेरा संविधान
महाजन अभी मैंने म्यूट कर दिया है हेलो हेलो महाजन नमस्कार गुरवर साहब, नमस्कार।
Namaskar, Mani Saab. So, good. Uh, I find AERB is already
है जी?
connected. So they will come on time then. I think yes. Good. तो आजकल वेबिनार आप खूब कर रहे हैं, एक के बाद एक।
है जी?
वेबिनार की
हाँ।
फ्रीक्वेंसी बहुत बढ़ गई है।
नहीं, अब तो बहुत 2 दिनों के बाद एक किया अभी।
या वही एक के बाद एक, पहले बायोगैस के ऊपर, उसके पहले कार्बन कैप्चर एंड यूज के ऊपर। नाउ अगेन यू हैव वन मोर शॉर्टली ऑन
अब
आरडीडीएस आरडीएसएस
इसके बाद 16 को है।
या यस, गुड मॉर्निंग शुक्ला जी।
Good morning, sir.
So you are in office? Yes, I can see that. I can see your
Yes,
office.
I am in office.
पहले मैंने सोचा मैं भी वहीं आ जाता, then I thought मैं भी घर से ही करता हूँ मैं।
That would have been better. Voice is clear, sir.
बिल्कुल क्लियर है, वॉइस भी क्लियर है, आपका कैमरा भी बिल्कुल ठीक है।
मेरी
I
मेरी
can
वॉइस
see very
क्लियर है?
well.
मेरी
क्या?
वॉइस क्लियर है?
बिल्कुल क्लियर है। I send this message on the. We have a WhatsApp group of INA fellows in Mumbai. I have sent it there also. Maybe 1 or 2 persons from there also may join.
मोस्ट वेलकम।
तो एटलीस्ट सनत कुमार जो है वो हमेशा ज्वाइन करते हैं। आई होप ही विल बी देयर। पूरे ग्रुप में आप
महाजन कहाँ चला गया? ग्रोवर साहब,
हाँ जी।
मैं महाजन कहाँ चला गया?
महाजन का यस, ही इज देयर।
आ
महाजन
गया, आ
इज
गया।
इस तरह से करता है।
यार बंद कर छोड़।
एक मिनट, इधर से कर दे। अगर यार खिसकी सारी खिसकी पड़ी है, उसको दबा दो उठा के। तो आपका चप्पल, और वो फिर मैं आई थी ना,
मैंने पोछा लगा दी थी पहले।
ग्रुप पे ज्वाइन ही किया।
इंडिया एनर्जी फोरम।
महाजन साहब कोई प्रेजेंटेशन तो नहीं है आज, पावर पॉइंट तो ट्रायल कर ले।
I don't know. He has not mentioned whether he will be making a presentation. करेंगे भी तो अपने वहीं से करेंगे.
हाँ नहीं, मैंने कहा ट्रायल कर लेते, वी हैव सम टाइम ना।
Grover साहब may be in a better position. ग्रोवर जी उन्होंने कुछ इंडिकेट किया?
किसको?
शुक्ला जी ने इंडिकेट किया कि
He is there online. You can see him there.
Good morning, sir. Welcome.
He will be sharing his PowerPoint. He's in office already. He will be sharing his PowerPoint from there.
Okay.
So shall I share? You want to just test?
टेस्ट कर लो, अच्छा रहेगा अभी से।
Yeah.
आप ये 5 मिनट
Okay.
है।
Yes, yes, okay. चलो बताओ यार अभी तुम। This one.
Yes, we can see the presentation.
Yes.
इसको फुल
This
स्क्रीन
one?
पे ले लो, देखो आगे चल रहा है आराम से या नहीं।
ये राइट वाला प्लग क्लिक।
इसका वो कहाँ गया यार, वो नीचे वाला आता है ना फुल।
फुल ये नीचे है, और नीचे आइए। हाँ इसके ऊपर वाला, इसके ऊपर वाला, हाँ ये।
Actually, in my screen there is some other thing is coming. Now I can see. Yes. Yeah.
हाँ हो गया।
Yes, it's okay. We can see
हाँ.
full screen now. इसको जरा
हाँ.
आगे एडवांस करके देख लो या।
So it is going ahead. And previous.
Page up and down.
I think it is moving.
Okay, good.
It is moving.
Yeah.
Okay. ये थोड़ा इधर ही रखोगे तो समझ में आएगा। So now I unshare then. Yeah, I will
फिलहाल
unshare.
अनशेयर करके बाद में दोबारा आ जाना।
किधर से करना है unshare?
हेलो रजनी।
हेलो महाजन,
कैसे हो?
नमस्कार शुक्ला जी।
नमस्कार मैडम, नमस्कार।
भंबानी जी।
हाँ जी।
शाही साहब का क्या न्यूज है?
शाही साहब आएंगे ना?
टाइम तो हो गया। वी हैव ऑलरेडी हैव 20 पार्टिसिपेंट्स। 5 मिनट और देखते हैं, वी कैन स्टार्ट।
वो मॉर्निंग फ्लाइट से आ रहे हैं वहां से, अहमदाबाद से। आई थिंक।
अच्छा, अहमदाबाद से आ रहे हैं। आज तो फ्लाइट्स डिले होंगी, काफी फॉग थी दिल्ली में, स्मॉग काफी थी आज।
दिल्ली में फॉग शुरू हो गया।
दिल्ली में स्मॉग आती है, स्मोक प्लस।
स्मॉग चल रहा है।
हाँ स्मॉग चल रहा है।
यहाँ बहुत पोल्यूशन है दिल्ली में आजकल।
दिल्ली में तो फ्लाइट्स की इस
हम्म।
मौसम में प्रॉब्लम होती ही होती है। गुड,
And-
मोर पीपल आर ज्वाइनिंग नाउ।
दिल्ली में एनवायरमेंटल पोल्यूशन भी है, पॉलिटिकल पोल्यूशन भी है, तो इस इकट्ठा अफेक्ट। मैसेज है उनका क्या कोई बमानी जी, मैसेज है उनका?
नहीं, मैसेज तो कोई नहीं है।
चलिए 2-3 मिनट और देखते हैं, देन वी कैन स्टार्ट।
हाँ।
शुक्ला जी वेट कर रहे हैं।
कईयों के फोटो नहीं आ रहे, कईयों के।
वो अपना कैमरा ऑफ कर रखा है।
कैमरा ऑफ करते हैं।
जो लोग नहा धो के शेव करके बैठे हैं वो तो कैमरा ऑन करेंगे।
परफ्यूम भी लगा
That feature will also come in technology.
AI will be applicable here also. Mumbai, how's the weather now? Cool down or still
नहीं
quite
बहुत गर्म है।
गर्म है?
बहुत गर्म है।
अच्छा।
Very sultry, sultry
हम्म।
is what we
Hot and
call
sultry and very dusty.
sultry, dusty, and in Dahlites language, it is sadi garmi.
सही बात है। दिल्ली में होती भी काफी सड़ी गर्मी में, पसीना बहुत आता है।
अभी
सफोकेशन।
मैं यही पढ़ रही थी, वॉशिंगटन, they are going to wash the roads. So Mumbai will become Washington.
अभी तो और 4-5 महीने पॉलिटिकल डस्ट काफी फैलेगी इंडिया में।
That's the price of
मैं नोट कर रहा हूँ कि शाही साहब जो है, he must have landed because I can reach, my message has reached him.
अच्छा, देखता हूँ।
Right to point here, देखते हैं कि-
You can join from his mobile.
Yeah, that's what.
महाजन साहब, भाई साहब को ट्राई कर रहे हो?
हाँ शाही साहब कनेक्ट कर रहे हैं। आई थिंक अनदर 2 मिनट्स। रावत जी
जी महाजन साहब।
ज्वाइन किया?
नहीं, भाई साहब को मैंने ट्राई किया था, वो
नहीं मेरी बात हुई है, उनका है मैं कर रहा हूँ, ध्यान कर रहा हूँ गाड़ी गाड़ी में से।
पर ठीक है, वो अहमदाबाद में ही है, ठीक है, तो अभी ज्वाइन कर लेंगे सर, कोई
अच्छा, he is not coming.
नो नो, अहमदाबाद में नहीं।
We have 40 participants so far.
सिंधु
एक जूम लेक्चर हो रहा है, मीटिंग वीडियो मेरा है, नहीं किसी और का। तो भी अर्चना लिंक भेजा, मैं उसको कनेक्ट किया, इसको शायद
Bambani sahab,
हाँ जी,
I think there are already 45 participants and 10 minutes over. We will start with the
काफी आगे।
introduction
हाँ,
portion.
साईं साहब आ रहे हैं
नहीं, I think he can join. उसके बाद पहले ग्रोवर साहब का वो रहेगा by that time.
हैं?
I think we can start by the time Grover Saab finishes his introduction to the topic. Shai Saab will be able to join. So I, on behalf of the India Energy Forum, would like to welcome all the participants to this very interesting topic on the safety and regulatory aspects of nuclear power generation. One thing is very clear that for the run up to our net zero targets by 2070, nuclear energy will play a very, very significant and important role. It has been proven without doubt that only with the renewable energy we will not be able to achieve these targets, and nuclear will have to play a very increasing role compared to whatever it has so far. And the generation from the nuclear fuels will have to be much more than what it is. However, one aspect which needs to be dispelled is the safety aspects of nuclear energy, whether it is a right perception or the misperception, but this doubt lingers on, and the slow progress, besides the high gestation period and lack of finances, one major reason has been this perception. And we are very fortunate that Shri Dinesh Kumar Shukla, who is the new chairman of AERB, he has agreed to dwell on these issues and cover the safety and regulatory aspects. Before we request him, I would request Dr. R.B. Grover, who is the chairman of the Nuclear Energy Vertical of India Energy Forum, member of Atomic Energy Commission, and earlier Vice Chancellor of Homi Bhabha Institute of Nuclear Sciences. He will be clarifying the aspects which are being covered in the today's presentation. So I would request Dr. Grover to kindly brief the about the topic, and then we could request Shai Saab before we make a request to Shukla Saab to give his presentation. Dr. Grover, please.
Thank you, Mr. Mahajan. Mr. D.K. Shukla, Chairman AERB and the main speaker for today's webinar. Shri R.V. Shahi, President IEF, who has just joined. He was traveling and he has joined now. Shri Bambani, Shri Mahajan, members of IEF and all other participants, a warm welcome to all of you. During the next 10 minutes or so, I will briefly touch upon the role that has to be played by nuclear energy in achieving a net zero energy mix by 2070 and bring out the context of the webinar today. The target of achieving a net zero by 2070 announced by India is an economy-wide target. Therefore, one has to look at all human activities that result in carbon emissions. Along with energy services, one has to look at industrial production, land use changes, and agriculture. At the present level of technology development, low carbon energy at scale is being provided by hydro, nuclear, solar, and wind. All these sources provide electricity. Therefore, to reach the target of net zero, electricity has to be generated by low carbon sources. End-use services have to be electrified, thereby increasing the share of electricity in the energy mix. Use of fossil fuels in the processes has to be replaced to the extent possible by electrified substitutes, and any residual usage of fossil fuel has to be accompanied by carbon capture, use, and sequestration, that is CCUS. India faces twin challenges of meeting the rising energy demand of a developing economy and ensuring an economy-wide low-carbon transition to stay on track with its decarbonization goal, leading to a net zero by 2070. As emissions from the use of fossil fuels remain the largest source of greenhouse gas emissions in the country, a massive restructuring of the energy sector is needed. To understand the magnitude of the challenge before us, the first step is to estimate the energy requirements for a developed India. There is a direct correlation between the Human Development Index, that is HDI, and the final energy consumption, that is FEC, and India needs to provide more per capita energy to improve HDI. India is a part of G20, and several nations comprising the G20 have an HDI above 0.9, and it should be our aim to reach 0.9 as soon as possible. Some expert estimates are available, and one expert estimate, which is very recent, tells us that India will reach HDI of 0.9 by 2053. To achieve an HDI of 0.9, FEC in India has to rise significantly. And also to achieve net zero, it has to be either in the form of electricity or hydrogen derivatives such as ammonia. While some hydrogen will be produced by biomass, by municipal waste, most will be produced by electrolyzers until we have high temperature reactors from which we can get hydrogen directly. Therefore, electricity generation has to increase for its direct use and also to generate hydrogen to replace fossil fuels for industrial use. Our estimates indicate that India has to plan to generate about 24,000 terawatt hour of electricity. There are some estimates which are above it. There are some estimates which are below it. So I'm sort of feeling that it is around this number, which is what we have to generate. A part of it, maybe 60%, will be used as electricity, and the rest for the generation of hydrogen by electrolyzers. One has to compare it with the current total generation of about 16 to 1700 terawatt hour per annum. And that tells us a gigantic task that lies before India to achieve a net zero by 2070. That can be done only by deploying a diverse mix of technologies. A diversity provides protection against disruptions. And no single source can meet the target demand of 24,000 terawatt hour per annum. Some hydrogen will be produced by other means as biomass, urban waste, etc. To that extent, this number of 24,000 will come down. So let us see, coming to nuclear, which has to play an increasing role as we proceed further. Characteristics of nuclear power have been studied over the last several decades, and its regulatory framework at the global level is well established. Earlier studies brought out positives like very low carbon emissions, low health externalities, low land footprint, and the ability to store fuel at the plant site for a long period. And recent studies are focusing on comparing the cost of integration of intermittent sources and nuclear. Without nuclear power, the cost of achieving an energy mix having low carbon emissions becomes very high. Therefore, the share of nuclear energy mix in India has to rise manifold as compared to the current level of 3%. Most of the nuclear power plants operating globally do not have load following capability, while next generation nuclear power plants having such capability should be developed. This issue can be addressed by alternate means. As large-scale hydrogen generation is a must for attaining a zero energy mix, one obvious way is to use electrolyzers to produce low-carbon hydrogen to meet industrial demand and also to shape the demand profile. A diverse mix of low-carbon generators and the use of electrolyzers and hydrogen storage for flexibility services addresses the twin objectives of energy sufficiency and industrial decarbonization simultaneously. A yet to be published study by us indicates that the current focus on depending solely on electricity storage for avoiding power curtailment and ensuring round-the-clock power supply when integrating high shares of renewable generators into the grid needs modification. The use of electrolyzers needs serious attention in this regard. To become a clean, green, and developed India, energy services need a massive expansion and restructuring, and one has to conduct system-level studies to arrive at a symbiosis between the use of electricity and hydrogen as energy carriers and their generation by low-carbon resources. And there is a hint about this, just a one sentence in the World Energy Outlook released just about a fortnight back by International Energy Agency. In India, the installed nuclear capacity is close to 7 gigawatts, and the generation by nuclear power plants in the previous financial year was about 47 terawatt hour, which is 3% of the total generation. At the start of nuclear power program, India opted for pressurized high water reactor technology, and that continues to be the mainstay of our nuclear power program. At present, India is constructing several 700 megawatt PSWRs. In addition to PSWRs, India has decided to go for light water reactors, and NPCIL is operating 2 large reactors which were constructed in technical collaboration with Russia, and 4 more are under construction, and these are in addition to the very first 2 reactors at Tarapur. In India, we have a well-established regulatory body, and today we'll know more about it from Chairman of the Atomic Energy Regulatory Board. I would just like to say that countries pursuing nuclear power or non-power applications of nuclear technology and nuclear industry have set up mechanisms at the global level to share operating experience, education and training resources, and safety and regulatory practices. And this is something unique for the nuclear sector, the global sharing of experiences. 2 important organizations at the global level which are working in this area are International Atomic Energy Agency, that is IAEA, and the World Association of Nuclear Operators, that is WANO. A set of codes and guides have been published by IAEA, and Indian experts have been participating in their development. WANO does peer review of operating reactors, and reactors in India have gone through peer review by outside experts. Indian experts participate in the peer review of reactors in other countries under the aegis of WANO. Basically to say that our system is well integrated at the global level. The Atomic Energy Regulatory Board was constituted in 1983 through a notification issued under the Atomic Energy Act of 1962. Since Mr. Aditya, please mute yourself. Mr. Aditya, please mute yourself.
Just start working.
Since its constitution, ARB has evolved into a highly competent.
Requesting all participants to please mute themselves. Only when they have to ask something, they should unmute. Please.
Since its constitution, ARB has evolved into a highly competent, knowledge-based organization regulating all aspects of nuclear safety and aspects of nuclear security that have a linkage with safety. For the execution of assigned functions, it deploys a large pool of highly trained and specialized manpower, and also draws on the expertise available in the country in academic institutions, research and development centers of the DAE, and also those who are superannuated from nuclear establishment. It has gone through a peer review under the Integrated Regulatory Review Service, IRRS, of the IAEA, and this is very important. IRRS has identified several good practices followed by ARB and has acknowledged its technical competence. India is a party to the Convention on Nuclear Safety and participates in the review meeting of contracting parties, and these meetings are held every 3 years. India has logged about 600 reactor years of safe operation. While this is an achievement by NPCIL, AERB also has played a role in realizing this particular achievement. And today we'll hear more about it from Shri D.K. Shukla, the chairman of the Atomic Energy Regulatory Board. Thank you. And
Thank you, Dr. Grover, for a very crisp overview of the energy scenario and the requirement of energy by the time we achieve net zero carbon emissions. May I now request Shri R.V. Sahi, who is the President of India Energy Forum, a former Secretary Power to the Government of India, to kindly give his address on the importance of nuclear power in the overall energy mix. Shri Sahi, please.
Thank you, Mahajanji. Respected Chairman of the Atomic Energy Regulatory Board, Sri Dinesh Kumar Shukla ji, respected Dr. Grover, Chairman of our nuclear vertical in the India Energy Forum, Mr. Mahajan, and distinguished participants, a large number of them. I think we already have almost 70. This is one of the very largely attended webinars that we have been conducting. On the nuclear itself, I think in the last about a little less than 3 years, 2.5 years, we might have done almost 4 or 5 programs on different aspects. And I would also say, but will not claim credit for this, but will definitely say that these programs and also what we have been working behind the scene on policy advocacy has helped, particularly in the last 2 to 3 years, to bring a larger amount of understanding and appreciation, and also some actions, good amount of actions on a little larger rate of expansion of nuclear power capacity. It has been slow. As mentioned by Dr. Grover, we have a little less than 7,000 megawatt of capacity in the country today. And that's what we have been able to achieve from almost 1960s when we decided to get into nuclear power to now. That means almost 60 years. It may be now 1.8% or 1.7%, but Dr. Grover said that in terms of power generation, it is close to 3%, which is very insignificant. And in the beginning of these discussions, we were concerned, and we were concerned to the extent that there are some very senior colleagues, experts in the energy sector, who use the phrase, is it a factor in the equation of energy management of the country? Is it in the margin, or it has to receive the right respect, the right recognition, and therefore appropriate action? And that is what drove us to have a larger amount of deliberation and discussion on the subject. That this is not okay. What we have done is, and now it is not okay in any case, in the context of the climate change discussions receiving a different level of understanding, different level of concern, and different level of response all over the country, and particularly in South Asia and in India. Because whatever we have been able to do in India to raise the per capita consumption of electricity, and that is insignificant. As a matter of fact, even if you don't compare with advanced countries, and we need not, but if you compare with China, right now India should be having almost 4 to 5 times of what it has. 4 to 5 times. Dr. Grover was giving a figure of tetrawatt hours, etc., etc. But what I'm saying, we are nowhere actually. We are 1/4 or 1/5 of what we should be. And the whole thing has to be seen in that context. That means 425 gigawatt or 425,000 megawatt of capacity and corresponding, let's say, tetrawatt hours of generation with all sources of energy, conventional, renewables, also nuclear, all sources of energy. We are absolutely at a very, we can feel happy that we have done. Most of it we have done in this century. When we entered this century, we were not even 100,000 megawatt. So today, at least, we are 425,000 megawatt approximately. But then that gives us a satisfaction that in this century of around 20 years, 22 years, we have added more than 300,000 megawatt. But then there is one way of looking at it, to be happy about it. But to be concerned about it and to be serious about it, one should also look at, even if we don't compare with highly advanced countries, and definitely we deserve to be at least compared with, if not at par with, China, and then we are far away. So issue here in all these discussions has been that it is not that nuclear power should be there or should not be there. It has been established that it is essential that it should have been much larger in terms of its contribution, in terms of its capacity, and we have not been able to do it. So that is the issue. And therefore, all types of discussions we have had. What is holding us? For many years, at least when we began this century, we were concerned about the fuel. Fuel problem has been, I wouldn't say, may not have been fully resolved for the level of capacity expansion that we are wanting, but substantially resolved. We were not there because we didn't have the nuclear supply agreement, etc., etc. So today we have. So we have the advantage of accessing nuclear fuel outside India. And to what extent, etc., one has to see. It will be commercial and so many other things. But till 2005, 6, 7, we had that issue. But now we don't have that. So therefore, from there also, we have passed 15 years. And these discussions have definitely led to a better awakening, better serious thoughts, more serious thoughts. And so many projects are being taken up not in discussion, but taken up seriously in terms of government deciding to invest, in terms of nuclear power being questioned, why are you not expanding? Instead of nuclear power being asked that, yes, why not? You should expand. And then why not we should improve your project management, etc., etc. In fact, another development during these discussions in the last 2 years has been that will only nuclear power corporation do it, or can they have joint venture? I have been supporting, I have been advocating that apart from many other regions, and I'm very serious about it, many other regions, we have been holding it on the ground that only nuclear power corporation or only this and that department can do. That's not fair. We were having the same thing in the case of conventional power in India until the time we had Electricity Act 2003. Till 2000, I told you, till 2002, 3, we didn't have even 1 lakh megawatt. So therefore, there is some thinking that is further required to the point of being open about it, because institutional support, financing, how long we can go on depending only on government budgetary support. So those are important things. Fortunately, those discussions have also come in the forefront of issue. Nuclear power, my view has been that if India becomes more than 800,000 megawatt by 2032, 33, and another 10 years, it becomes 1,600,000, doubling of that, 1,500 to 1,600,000 megawatt. And if you are only 5% in next 20 years, then that 5% will meet, I have put it in one of my papers, something like 75,000 megawatt of nuclear power capacity. They mean more than 10 times of what it has. So I think country and many of us who are in this sector, energy sector, absolutely we have no doubt in our mind that there is no debate whether or not. Debate is why not. And debate is what we need to do that it is there. All the things. One of the, financing definitely. Financing you can, I asked the chairman of the Nuclear Power Corporation, why is it that you have not listed? Why are you not accessing capital market? Accessing capital market does not mean you are losing control. No types of control, neither financial control, nor safety control, nor any control. Government support should definitely be there, but there are companies, industrial growth has happened in terms of accessing capital market. We can't only think that we will do it, but financing will be done only when government gives us the money. So these are the issues which we have raised. So now, one of the issues that has been often raised in the country, and I wouldn't say that that is something which is insurmountable and it is excessive, is about concern for nuclear power. In many places, large nuclear capacity people have registered on the ground that would it lead to something big problem. And that is the issue that today we are going to get better education from Mr. Shukla. That means one is the truth of the matter. One is that our technical, professional, and regulatory competence all integrated together are such that we have overcome this problem. I mean, it's not that way I have complimented in our entire nuclear family, nuclear scientists and engineers, that we have done a commendable job. We have a very excellent track record of commissioning and operating these power plants. So therefore, one cannot say that that expertise we do not have, or that awareness we don't have, and that sense of responsibility we do not have. We cannot say. We have demonstrated that we do have, and we have done a good job. Has it gone down the line in the entire public, people who have been, or NGOs, who have been mentioning about this, raising concerns? Whenever we want to do a large capacity nuclear establishment, there are resistances, pocket of resistances here and there. Another thing is that one is that trying to do a better degree of advocacy and better degree of awareness programs, better degree of trying to create understanding on this issue. Another is tightening up our own really safeguarding mechanism, regulatory mechanism. I have no reason to believe that we do not have an excellent set of document, the policy, the guidelines, the SOP we have. I have no doubt that they are being implemented, properly they are being implemented. Are there gaps? Have there been any such, what are the mechanisms? So those are the issues, but more importantly, it is also the issue of creating, because now if we are going to raise our bar from 7,000 megawatt, I'm saying the country deserves 75,000 megawatt in 20 years from nuclear. May happen, may not happen. But if we are thinking in terms of those figures, this part of the challenge of safeguarding from the point of view of safety, security, and other regulatory aspects, whether we are fully okay or something more is required, that is number one, technically, professionally. Secondly, do we have mechanism to let people, the whole country be behind us, that look, in today's context, this is one of the best solutions for our carbon problem. It is carbon-free power. And we are thinking of battery, we are thinking of hydrogen, some of the points in an excellent deliberation Dr. Grover just now mentioned. He was giving several aspects of it. But this is also one of the most important tools to be backup for solar and to provide adequate amount of electricity, which is carbon-free. So therefore, this is going to serve the purpose of India's ambition on net zero by 2070. By 2070, we have to be net zero. What type of dimension and what type of proportion nuclear power will occupy will depend on what we do now. I mean, let's not go on researching why we did not do in last 60 years, but let us see what we do in next 50 years, that it brings us at least there, if not more than that. And in that, what would be the role of our safety and regulatory mechanism, which will provide a larger degree of confidence among people, and therefore a larger degree of support and acceptance of this technology. Whether it is a large reactor or it is small or medium reactors, that is also one session we want to do, because there have been thoughts on the subject, but we have not cleansed that issue. And once we clean that issue again on advocacy, we should go whole hog. That in our old plants, coal plants that are sort of uprooted, do we have a scope for having small and medium reactors? Are there issues? What I vaguely think that there are different perspectives on this. So from the nuclear engineers and nuclear scientists, we should get a sort of unified perspective that can SMR also occupy certain proportion of this respectful position in the next 50 years or 40 years or whatever time dimension. With these words, I will listen to the deliberations and then also come at the end. Thank you very much.
Thank you, Shahi Saab. You have laid the roadmap to the importance and contribution of the nuclear energy in the overall power programs. One thing which you have been advocating, that even if we have to increase the present generation capacity from 7 gigawatt to about 75 gigawatt in the next 2 decades, the nuclear power contribution in the overall energy will only be 5%.
Yes, exactly.
So there is a lot of scope for giving much more importance to this form of energy if we have to reach the levels of the energy requirement, which Dr. Grover also mentioned, 24,000 terawatt. The aspects which have been worrying about single agency execution and perceptions of the safety aspects, is very appropriate that we have organized this webinar to hear the views on the regulation aspects and the safety aspects from none other than the chairman of the Atomic Energy Regulatory Board, Shri Dinesh Kumar Shukla. Before I request him to give his presentation, let me very briefly remind the participants that Mr. Shukla has taken over as the chairman Atomic Energy Regulatory Board with effect from January 1st, 2023. He is a graduate mechanical engineer with 4 decades of experience in operation and regulation of nuclear, radiation, and industrial facilities. Shuklaji, before joining AERP in 2015, had served Bhabha Atomic Research Center, BARC, for about 33 years in various capacities, the last one being as head reactor operations division. Shri Shukla has been providing consultancy to IAEA on matters related to safety of research and power reactors, document preparation, and for preparation of programs for various IAEA international conferences. Shuklaji is a member of the IAEA Commission on Safety Standards. His work in areas of human organization and technical factors for safety, safety security, interface, safety culture have been well acknowledged nationally and internationally. We are indeed very grateful to Shuklaji for having agreed to deliver his keynote address on a very important subject, which is in the minds of most of the population about the safety aspects. And he will also share what are the regulations to ensure that the nuclear power generation is in a safe mode. We would request Shuklaji to kindly start his presentation.
Thank you very much for nice introduction. And let me first share the slides and then. Yes. I hope you are able to see the screen.
Yes, please go ahead.
Yeah. Shri R.V. Sahi, President IEF, Shri Bhavani, Shri S.M. Mahajan, Convener Nuclear Group, Dr. R.B. Grover, Chairman Nuclear Energy Vertical IEF, members of IEF, and dear participants. A very good morning, and thanks to Dr. Grover and Dr. Shahi for making my work easy, as they have spelled out various things, and now the expectations which are people are or participants may be looking for from this presentation. I hope that I would be satisfying you people. So before I embark on the core subject of safety and regulatory aspects of NPPs, let me quickly brush through the initial development of technology and its regulation, because it has its own significance. So here is the Indian nuclear program, which is largely homegrown, and technology deployment and capacity expansion had a strong backing of long-term R&D. If you notice here, the base of the whole program is human resource development and knowledge management, and which is governed by the vision for human resource development of Dr. Homi Bhabha, given in 1944, which states, when nuclear energy has been successfully applied for power production in, say, a couple of decades from now, India will not have to look abroad for its experts, but will find them ready at hand. And this led to the establishment of training centers right in 1957. And you can see the today training centers are spread across India with capacity of training more than 500 fresh engineers and scientists in a year. So just recap of what I said about the Indian Atomic Energy Program. Robust R&D program, infrastructure for human resource development and knowledge management, fuel cycle capabilities, mining to waste management, industrial support, manufacturing and construction, and most importantly, the distinct features, which is the continuity. Now, this is very important compared to many other countries, that our program, there were changes in the pace, but it never got stopped. And this is what is one of the important feature of our program. And next is the strong government support. So after having glimpses of Indian nuclear program, let us move on to the safety regulation. And here comes the governing vision of nuclear safety regulation, again given by our founder, Dr. Homi J. Bhabha, which says that radioactive material and sources of radiation should be handled in atomic energy establishment in a manner which not only ensures that no harm can come to workers in the establishment or anyone else, but also in an exemplary manner, so as to set a standard which other organizations in the country make to be asked to emulate. So this is what is the vision, and this led to the emphasis on self-regulation. And accordingly, in the initial phase of the program, the concurrent development of regulation took place with the technology, and this continued for initial research reactors and then Tarapur plants, that BWRs 1 and 2 at Tarapur, and then Rajasthan Atomic Power Stations 1 and 2. And then came the expanding phase, and so the need for functional separation. So concurrent development cannot go together with the technology and the regulation. A functional separation was needed, and accordingly in 1983, Atomic Energy Regulatory Board was established as National Nuclear Safety Regulator. With this organizational setup, where Atomic Energy Commission, which is the apex policy making body, and it has the full administrative and financial power within the budget approved by the parliament. So it is as good as Government of India with respect to the matter concerning to atomic energy. And Atomic Energy Regulatory Board reports to Atomic Energy Commission. And as per the Government of India allocation of business rules, the nodal agency of government for atomic energy matters is DAE, and DAE provides the respective required administrative support to Atomic Energy Commission as well as Atomic Energy Regulatory Board to have its interface with the government. Now, this arrangement provides the required functional separation with DAE without isolation. This is what is to be underlined, that it provides the functional separation without isolation. And coming to the good practices and approaches to safety regulation, AERB shares the same DNA of scientific establishment, that is BARC, from where it has evolved, and it has inherited the good practices of multi-tier system of safety review and assessments, regulations based on sound scientific principles, experience of concurrent development of regulation with technology, because this helps in making or developing the practical regulations, adheres to key principles of functional independence, respecting the fact that prime responsibility for safety rests with the licensee. AERB ensures that the licensee is adequately discharging its prime responsibility for safety. So there are two pillars of safety, and we need to strike a balance between the two. The first one is the rule-based safety, where all situations are anticipated and accordingly formal procedures, rules, training, implementation of scientific and technical knowledge, these are formulated in advance. The second one is the managed safety, or what we call as a knowledge-based safety, where unexpected situations are handled as they arise. Human expertise, quality of initiatives, and management assume significant importance, especially for NPPs being knowledge-intensive technology, where everything cannot be tied to the rules. So they not only just coexist, but converge and develop jointly. The wisdom of this balancing comes with the maturity, and which AERB as well as its licensee, they have attained over the years. With this background, the approach to safety regulation, which is adopted by AERB, is knowledge come rule based, wisdom to choose and combine in appropriate proportion, emphasis on influencing over enforcement, because we look for enforcement as a last resort. First, we try to influence the licensee. Inclusive, participative, yet independent. This I will elaborate further. Now, before proceeding to safety and regulatory aspect, let us have a clear understanding of control and safety regulation. So there are two parts in regulations. So if you see the control part, it concentrates on what activities to be permitted. And here national policies, they come into the picture. Strategic requirements, international considerations, including diplomatic terms with respect to trade and commerce, defense, etc. The next is where to be permitted. So first, what activities are to be permitted, where to be permitted, that is site selection. This part also comes under part of the control, where grid needs and where, and there could be some political considerations also. They affect the where to be permitted, that is site selection. And the third one is the who should be permitted. Now, here comes the capability, that is organizational, financial, safety of workers, plus security of sources, etc. So input from safety regulator may be taken, but if you see the control part is purely policy part and to be taken care by the government of India. And once this control part is taken care, then comes the safety in the permitted activities at the selected site. And here comes the safety regulation. So robust control and safety regulatory framework exists. So control of nuclear facilities and material is with the government of India, that is concerned department is Department of Atomic Energy. For radiation application, some part is with the Department of Atomic Energy. Example one is the food irradiation and some other. And similarly with other line ministries under the relevant law, like radiation generating equipment or sources, that is with the DGFT. And environmental protection is regulated by, as per the Environment Protection Act 1986, by Ministry of Environment, Forest and Climate Change, and public consultation is part of the environment clearance. And once these things are done, then comes the nuclear and radiation safety, which is regulated by Atomic Energy Regulatory Board. So this is just a glimpse of legal and regulatory framework. That act is there. There are multiple rules under it, and civil liability for nuclear damage act and rules are also there, and associated acts are also there, like EPA I have already talked, Disaster Management Act, then Indian Electricity Act, and Air and Water Acts, the Explosive Act. So these are, and the Indian Boiler Acts also, because some places that is also needed. For simplification and consistency, an attempt is being made to integrate this multiple rules into single framework. That work is going on. Within the legal provisions of Act and rules, AERB develops the regulatory requirements and guidance documents, and AERB has issued 165 reg docs covering all consenting stages from cradle to grave. So it starts from the siting to all the stages are covered, and already experience exists with the diverse NPPs regulations, PHWRs, LWR, and even sodium cooled reactors. So how do AERB regulate? For this, AERB develops the safety requirements and guidance documents and ensures compliance with them. And for that, it resorts to the licensing. And this licensing is supported by two complementary processes: safety review and assessment and regulatory inspections. And once license is issued, then it ensures the compliance with license conditions, and where needed, it resorts to enforcement. And throughout the lifetime, this cycle continues, and all regulatory processes of AERB, they take into account systematic approach for human organization and technical factors and application of graded approach. That is, the extent of regulation depends on the significance of the safety for that particular activity. And at the same time, this operation and regulatory experience feedback is utilized to further update the regulatory requirements. So regulatory oversight from cradle to grave, siting. So chosen, the selection of the site, as I said, is part of the control, but the evaluation of the site with respect to safety is the part of safety regulation and is being done by the AERB. Then comes the construction, where the plant design and applicants' statements and commitments meet regulatory requirements, construction meets quality requirements, these are checked. And next stage is the commissioning, where performance of the plant is as per design intent. Results of tests confirm the adequacy of design for regular plant operation. And then comes the final licensing stage of operation, where operational limits and conditions are checked to be consistent with regulatory requirements. adequate level of safety is maintained during operation. This is assured. And last one is the decommissioning. So AERB has integrated its all regulatory and management processes into a single framework of integrated management system. And this document is available on our website, which covers, if you see, the mission, vision, organizational policies, functional mandate, organizational strategies, organizational structure, responsibilities, regulatory and management processes, and most importantly, the decision-making and communicating decision. No other part than the how decisions are made in organization tells about the organization, what the organization is. It is known the way decisions are taken, and these are available publicly in our website. And the application of graded approach for regulation through formal guidance. There is a formal guidance available to our staff. Similarly, a formal guidance for establishing multi-tier review mechanism, its interfaces and assessment is also available. So what is the focus of regulation? Who is the focus of regulatory oversight program? It is the licensee who has the primary responsibility for safety. Licensee's background, that is the experience and maturity, and safety performance are important factors in deciding scope and depth of regulatory attention. And then what is the focus of regulatory oversight? It is to verify effective implementation of a licensee's management system of all phases of a facility's life cycle, with particular focus on oversight of agencies involved in design, construction, commissioning, operation, maintenance activities. AERB's oversight provides independent verification that requirements have been met, with emphasis on making the licensee aware of its primary responsibility for safety. The most appropriate regulatory focus is on encouraging the licensee to self-identify, understand, and take ownership of safety issues and improvements, because it is the licensee who is primarily responsible for safe operations. However, a flexible approach is adopted as it is sometimes necessary to reinforce messages through formal processes, which may include enforcement tools. It is important to encourage the licensee to analyze perceived issues in more depth and reinforce the need for continuous rather than a one-time improvement program. So with this, we come to the actual licensing process. So here is the applicant, which is the responsible organization, and what is expected from the responsible organizations. You can see here that responsible organization is supposed to own the design, and for this, it should have a capability for independent assessment, availability of technical documents and drawings, updated information on design and technical details of system structures and components, acquire and provide necessary information on set of computer codes for lifetime safe management of the facilities, and manage a smooth manufacturing, construction, erection, commissioning, operation, and decommissioning of SSCs. So the licensing basis, there are generic requirements which are technology neutral, robust design safety, quality assurance, radiation protection, emergency preparedness, waste management, and site evaluation. And for all these regulatory documents and requirements, as well as the guidance, both are available. Then there are certain technology specific requirements, specific system requirement, technology specific hazards. So here comes the plant states. Now, prior to this Fukushima accident, actually this plant design envelope used to end here. That is, it was covering up to the design basis accidents only. After post-Fukushima, now that safety codes have been revised, where this plant design envelope has been extended to include design extension conditions also. So in this case, that for normal operation, you are supposed to have the robust design, then anticipated operational occurrences, which you expect once in a while in the lifetime of the facility to occur. And for them, the dose limits are restricted to the public to 1 millisievert. That is normal operation as well as anticipated operational occurrences. While when it comes to the design basis accidents, which takes into account single failure and consequent failures into account, and credit of the safety systems available. Here, that requirement is that no need for off-site countermeasures in case of a design basis accident, and realistic analysis is permitted. Dose to the public must be limited to 20 millisievert per year. And then comes the here design basis accident, only single failure things are considered, while when we consider multiple failures and rare external events, then it goes into the design extension condition. And for design extension condition A, where that it is without core damage, same dose criteria of 20 millisievert per year is adopted. But there should not be any need for sheltering and evacuation. Distribution of prophylaxis can be allowed. And when it comes to the deck B condition, where with core damage, there also that requirement is that no permanent relocation should be required after such accident, and off-site intervention should be limited in area and time. And this is kept as qualitative. It has not been very specifically made, but there is a safety manual being prepared, which will provide the full guidance that how this qualitative criteria to be met. And conditions beyond design extension condition B, they are supposed to be practically eliminated, either by demonstrating that they are highly likely conditions, physically impossible, or through the reliability analysis that they are highly unlikely conditions. So these are the things, and these accident conditions, they are in the decreasing order of frequency. So robust design safety is required to ensure that the fundamental safety functions of control of reactivity, removal of heat, and confinement of radioactive materials are met continuously. And this assurance comes from application of concept of defense in depth, good design considerations, single failure through redundancy, common cause failures through diversities, and fail-safe design, assured safety even in failed state, and designed to ensure very low risk. Events with significant frequency of occurrence should result in no or minor consequences. Events with high radiological consequences should have very low frequency of occurrence or practically eliminated. And the verification of these are done through the deterministic safety analysis and probabilistic safety analysis. So coming to the defense in depth, it is a concept of independent and subsequent layers of safety measures. Key is creating multiple independent layers of defenses to compensate for potential failures so that no single layer, no matter how robust, is exclusively relied upon. DID includes the use of redundant and diverse layers, physical barriers, procedural barriers, ensuring SSE of highest standard, monitoring healthiness of defenses, and assessment of safe operation for given period. Now here you can see that normal operation, then moving to the, so design has to provide the confidence that in normal operation, design and specification will be met. And in case of anticipated operational operations, provision should be made to control and bring back to the normal operation. Similarly, in case of design basis accident, design provisions, engineered safety features are to be provided to take care that those criteria. Similarly for DAC A and DAC B. And this we will see in a little more detail. So here you can see that defense in depth is elaborated in more things. The first level, that objective is prevention of abnormal operation and failures. Essential means are conservative design and highly quality in construction and operation, control of main plant parameter inside defined limits, and radiological consequences, as I said, that no off-site radiological impact bounded by regulatory operating limits for discharges. So this associated plant condition is normal operation. Then next we go to the level 2, where the condition associated is anticipated operational occurrences, where objective is to control the abnormal operation and detection of failures, and means are controlling, limiting and protecting system and the surveillance features, and those criteria radiological impact remains the same. Level 3 is the postulated single initiating event and consequential failures. This is the design basis accident. And here the objective is control of accidents within the design basis, design provisions, safety systems, and emergency operating procedures. And then when suppose these 3 levels have failed and we enter into the postulated multiple failures and events, that is design extension conditions without core melt, then the objective is the control of accident to limit radiological releases and prevent escalation to core melt conditions. Essential means are through the additional safety features and accident procedures, and no offsite radiological impact or only minor radiological impact. That is, only prophylaxis can be distributed, while the dose criteria remains the same as for the DBA. Even if suppose it escalates accident condition to the next level where the core melt takes place, then the objective is by the design is to control of accidents with core melt to limit offsite releases. Compensatory and safety features are provided to mitigate core melt, management of accident with core melt, severe accidents, and offsite radiological impact may imply limited protective measures in the area and time. So after all these things, also suppose accidents percolates to the level 5, where we say that offsite conditions have generated, then the objective is to mitigate the radiological consequences of significant release of radioactive material, and essential means are through the offsite emergency response and intervention levels, and offsite radiological impact necessitating protective measures. So this is the way defense in depth is taken care. This is which differentiate this nuclear power plant from the conventional power plants. And just a word of caution. While DID, I say that it has the mixed blessings. While it greatly reduces likelihood of a severe accident, but at the same time, it renders system opaque to the people who manage and operate them. And this can lead to a tendency to compromise on the competency for obvious reasons. So in a well-defended system, such as NPP, only safety cultural influences are sufficiently widespread to increase substantially the probability of lining up a penetrable series of defensive weaknesses. This is what that reason has brought it forward, that all defenses can come, and it is through only the safety culture which can influence and have everything aligned to lead to a accident. And because of this, modern high-tech, well-defended technologies such as NPPs are more vulnerable to the effects of a poor safety culture or poor management of human organization factors than the traditional industries. So the ultimate DID, if you see, is the competency and safety culture. This is just a summary of what I have said earlier, that how the consenting is done, and you can see it is through the responsible organization and regulatory body interaction, all these stages are taken care of. Specifically with respect to manufacturing, AERB does not directly put its oversight on the manufacturing, but it is through the responsible organization. So responsible organization should ensure the provision for AERB's access to the manufacturing units, where the role of AERB is limited to check how responsible organization is implementing its QA program. So safety review and licensing of new build is applicable AERB, generic and current safety requirements are to be met. Applicable IAEA and international requirements are to be met. First of its kind systems, the complete spectrum of safety functional demonstration by technical inputs and R&D experiments, that is the basis of acceptance. Extensive commissioning test and additional surveillance to the extent practicable. Experience feedback from similar design, in-house checks and analysis. For imported NPPs, the plant should be licensable in the exporting country. Operating experience feedback, that means there should be a reference plant. And the design authority. Hello?
Shuklaji, you continue.
Yeah. Design authority and plant life management. Now, this is very important because when you import the thing and if you don't have a design authority within our country, which has the full thing, which I had explained when I was explaining the responsible organization, then you become actually really incapable of providing the input, whatever a regulator needs. So that's why a capability or technical compatibility and competence with respect to the full design information should be available within the responsible organization. And this is how this multi-tier safety review mechanism works. It safeguards against decision-making traps and biases, such as anchoring trap, the individual and team biases, and also sunk cost trap, etc. So here the emphasis is that the first level, it will be the AERB staff, in-house working groups within AERB, and task forces and expert groups. This is all within AERB. They will come out with a full review outcome that will go to the next safety committee, and that output further will go to the advisory committee and finally to the AERB board. And the integrated management system, where I was talking about the decision-making level and associated review levels, as per the graded approach, they are very well defined over there. Everything does not follow all the sequential things. Something may end here, something may go here, something to here, and something to all the levels, depending on the safety significance. Besides this, AERB takes technical support from R&D institutes such as BARC, academic institutions such as IITs, and retired experts. So, coming to the role of regulator, what is the role of a regulator? It is to reduce the risk to the stakeholder, that is for us, it is the public. And this is the reason why we adopted IMS from ISO, because ISO was not accepting our this part. They say no, stakeholder, your stakeholder is licensee, so you have to work to satisfy your stakeholder, which was conflict of interest. So we have dumped the ISO and adopted our own integrated management system. While making risk acceptable to the stakeholder, it is to be done with the ease of meeting regulatory requirements by the applicant and licensee. So this is what the role of regulator. It should not be made too difficult for licensee and applicant to meet the regulatory requirement, while satisfying this part, that making risk acceptable to the public, but at the same time, it should be done with the ease. And for this, what is being done is the effective management of resources and new initiatives. So major resource available with the regulator is the regulatory safety codes, safety guides, and safety standards. This we have taken up a holistic revisit and revision. For last 4 years, we are working on it continuously for clarity, simplicity, consistency, and harmony among them, as well as with the legal provisions and current international standards. This is in progress. You must appreciate that many of these legal provisions, they have come in different timelines. Similarly, our courts have also come in the different timelines, so that inconsistency is bound to happen. So this we are trying to bring in that holistic revision to make them simple, consistent, and aligning the legal provisions appropriately. And in case of any experience of event in NPP, regulatory requirements may change. Recent example is post Fukushima, we have to change. Careful consideration for graded implementation of compliance to change requirements. And this has been done very satisfactorily by AERB, that appropriately graded approach was implied to complete. And almost now we are at the end, that where all the requirements, whatever has been imposed, are being met by the licensees. And this brings out the typicality of nuclear technology, because accident anywhere is having impact everywhere. Then coming to further that effective management of resources, the new initiatives, revision of consenting processes of NPPs. So we are targeting that simplification and introducing this pre-project consultation, so that the licensees really, particularly in the new scenario where the new licenses may come rather than the NPCIL, there could be joint ventures, there could be independent NTPC may approach, all those things may open. So we are preparing ourselves for that. So pre-project consultation, which will really explain them that what are the expectations of the regulator. Synchronization of licenses, as on today that AERB has been issuing this one license under radiation protection rules, another license as under the Factory Act, and authorization for waste management. Thus 3 things were being separately done. Now we have synchronized them already into a single thing, but now it is to go in the requirement document, that now single license will take care of all the 3. Long-term license for design life, as present practice is that every 5 years the license is renewed, which we are looking for to provide for a long-term 40 years, or the design life proven by the demonstrated by safety documents by the licensee, whichever is less. So that is what is being proposed, and it is in advanced stage of approval. I hope that in few months from now, we will be issuing this requirement document. And for repeat design, we have already implemented this part, that attention is being made to the changes from the earlier approved design. We are not reopening that whatever has been earlier approved for that particular design. Application of graded approach for optimization of review levels, implementation of integrated management system, we have already done, which I just explained. And guidance also is available for the application of graded approach. Competency development for new technologies. For this, AERB is participating in national, international forums and peer reviews. Further, we are looking for delinked site and design reviews. This is additional option to existing consenting process. As on today, that once project is proposed, then site and design put together is seen. Now it can be, site can be decided right away, and we can review it and have a review note available, which can be integrated when the design is proposed. So both can be integrated, and there that definitely our regulatory review time.
का फोटो लेना
Concerns with the new designs, it could be with the basic concept itself. There could be issues with the design standards used by vendors, materials used in design, research and experimental studies. So intrusive review is required when we have the new designs, and this would be intrusive review would be as explained under FOK system earlier. And just the presence of AERB, we are here in AERB headquarters in Mumbai. We have 2 buildings and third building is also now ready. We are waiting for the occupation certificate. Then there is a Northern Regional Regulatory Center in Delhi. There is a Eastern Regional Regulatory Center in Kolkata. There is a Southern Regional Regulatory Center in Chennai, and there is a Safety Research Institute in Kalpakkam. So, as we talked about the independence of regulator, if you see the competence independence is the most important attribute for the independence of regulator than the political independence, because this competence hampers, and it is a recurring thing every day you will be facing. While that political interference is a possibility, may come, may not come, but it would be once in a while, not every day. While the competence impedance, competence affects every day. So AERB puts lot of emphasis on human resource and knowledge management, and therefore it recruits or induct fresh recruits through training centers. And here that our feature of functional independence or functional separation without isolation serves the purpose, because we can directly track from the DAE training schools, fellowship programs of academic institutes we have, lateral induction of experienced personnel also we do, then training of our
Request-
people we send them to
requesting all participants to kindly
So training of our people is done at the NPPs for developing competence in NPP systems and O&M, orientation training and refresher courses on regulatory activities, and competency management. We identify the training requirements and update every year. And this, our strategy, it provides the appropriate balance of new and experienced human resources. And that's why our average age remains quite low compared to other organizations. And we have almost 368 competent officers working in AERB. International cooperation, I think already Dr. Grover has highlighted this part. So I am just bringing out that AERB maintains regular technical interactions with regulatory bodies of other countries for the exchange of information in the field of regulation of nuclear activities for peaceful purposes, to be at par with the international benchmarks. This Convention of Nuclear Safety, where the chairman AERB leads the almost 15-member delegation to the IAEA, and this recently we had in March, April, I had led the delegation, and we had very good outcome. Almost 8 good areas of performances were selected from India. Incident reporting database and all these things, we are part and parcel of thing. We are participating in OECD Nuclear Energy Agency also, in its CSNI working groups and CNRI working groups. Now coming to the international peer review, what way AERB is looked by them. So IAEA Integrated Regulatory Review Service Team, their observation during their initial mission, which took place in 2015, what they said is AERB has implemented the measures to obtain the technical expertise and capability which may be required to support delivery of the AERB mandate. Considering the powers conferred by its constitution, the AERB has the necessary legal authority for its regulatory activities. The mandate of the AERB does not include any functions other than regulation of nuclear and radiation safety. These provide functional independence for the AERB as a regulator. And after that, we had a follow-up mission, because in March 2015 mission, they had given 13 recommendations and 21 suggestions. So there has to be a follow-up mission to take care whether these recommendations are met or not. So we had this follow-up mission in June 2020 with extended scope to radiation sources also. And here, out of these 13, 11 recommendations have been closed. One recommendation is with respect to the de jure independence of AERB. They accepted that de facto independence is there, but de jure is not there. So the de jure independence is beyond anyway. AERB could not do it because it is part and parcel of government. So that remained, and one was on the HR plan, which was available but not signed document. So because of that, one recommendation remained. And 20 suggestions of 21 suggestions given have been closed. One remained with respect to that our communication strategy. Again, here it was not formally issued, so it remained. No new findings in relation to the topics covered during the initial IRRS mission, and extended scope of radiation sources has fetched only 3 recommendations and 3 suggestions. So the IAEA team noted India's regulator showed a strong commitment and professionalism to ensure nuclear and radiation safety in the country. The team observed AERB has acted on all the recommendations and suggestions of the initial mission of 2015, and as a result, significant improvements have been made in many areas. So these are some of the areas where they have recorded the achievements. Improved inspection program, including enhanced training and strengthening the power of inspectors, staff qualification and training programs aimed at building and maintaining expertise necessary for discharging its responsibilities, process for regularly reviewing regulations and guides. With this, I come up to sum up whatever I have said. The Atomic Energy Act 1962 and the rules framed under it provide adequate legal framework for safety regulation of nuclear and radiation facilities. India has established necessary infrastructure and regulatory process for effective implementation of legislative provisions to ensure safety of nuclear and radiation facilities. India follows a unique strategy in regulatory processes to cater to the strenuous demands of wide-ranging technologies. Already we are regulating PHWR, BWR, PWR, and fast reactors. Unlike other power industry, nuclear industry demands defense in depth with independent or common cause failure causing no impact, compliance to highest design standards, best quality compliance, and continuous monitoring and oversight. The regulatory approach followed is inclusive, participative, flexible, facility-specific, and balances well rule-based safety and knowledge-based safety to regulate any kind of technology without compromising on safety. The accident-free performance of nuclear facilities in the country over the years and the acknowledgement of IRRS IAEA peer review are testimony to the effectiveness of Indian safety regulation and commitment for ensuring high level of safety in nuclear facilities and activities. Thank you.
Thank you, Shukla Saab, for a very, very exhaustive coverage on the safety aspects and the regulations in force to ensure the safety of the nuclear power plants. The multi-tier safety aspects, they're definitely very, very encouraging, and the regulations are much stringent compared to the normal or the conventional power plants. Now, I'm sure the 85 participants to this webinar must be itching to have certain clarifications and further elaboration from you. So I will not come in their way and request Dr. Grover to kindly moderate the interaction session.
Thank you, Mr. Mahajan and Shuklaji. It was a very, very well organized lecture full of information. So now let us see how many questions we have. Right in the beginning, I find 86 participants continuing, which is not always the case in webinars. So now you are going to have some questions. Let us open it to the audience. Questions, please. Maybe you can stop sharing the screen now.
Oh, sure.
Yes. Okay. Audience, who will start first? I think everything is so clear that no questions.
Hello.
Yes, Mr. Amol.
Yeah, yes, sir. So I wanted to ask just a very basic question, like what is the basic difference between safety code, safety guide, and safety standard? So just, I mean, in a very naive terminology, if you can.
Yeah, no, sure. The very appropriate, very appropriate. We have come
Yeah.
out with a thing. Actually, in our code, we explain these things. Code is primarily safety code. What we say is they are the safety requirements. They are to be met. Safety standards are like you have that for design, you have like ASME is a standard which is for designing a particular system, equipment, or a structure. So our safety standard is with respect to the radiation safety part. So they give the standards to which you can comply. Requirements are covered in the code. Code does not give the requirement. And guide as it comes, once requirements are given, then the guide gives the recommendations how to meet those requirements and certain elaboration of the requirements. Because many a times you will find in code, requirement would be very crisp. While guide will elaborate on it and provide a well reviewed and accepted mechanism to meet those requirements. So suppose if a licensee meet and says that I am meeting this requirement as per this guide, whatever mechanism is given, then AERB doesn't have to re-review it because that mechanism is already reviewed through multi-tier and accepted. But if suppose option is available, if suppose somebody wants something different than that, which is given in the guide, he can still meet with the requirement. Then we have to go through that multi-tier review process. That is the only difference.
Yeah. Thank you, sir.
I have one question, Grover sir.
Yeah, please go ahead.
I would say that the safety regulations enforced by Department of Atomic Energy have been excellent, and to the best of my knowledge, the 23 power plants which are generating nuclear power, there has not been even a minor accident in that. So this is very highly appreciative of the AERB to ensure the safety aspects of the operation. In the design aspects, of course, you are taking care of, but in the operation also, the record has been very, very impressive. My question relates to other aspects of utilization of the nuclear energy for the medical use. It may not be coming under your purview, but we don't seem to be concerned about the radiation being emitted and absorbed by the patients when they get subjected to nuclear medicine and nuclear tests. Is there any regulation to control that, and is that being monitored regularly also? And what are the levels? What would be your recommendation on the frequency of these tests being conducted? Today, unfortunately, if you go to a doctor, he will prescribe something related to a radiographic examination, whether it is based upon any other ailment. So the exposure keeps on increasing with the number of tests being prescribed for the patients. I would like you to share the safety aspects of the equipment as well as the radiation being absorbed by the patients. How frequently it should be, it should not be recommended. May not be related to the power generation, but then
no, this is okay. I think Shuklaji, there is the answer readily available. Shuklaji.
No, I will give that. Actually, first, thank you very much for asking this question. And I will say the audience, please go to our website. On the website, recently, I had shared the stage with the governor of Maharashtra in the World Cardiologist Conference, where exactly what you have raised, this is what I had brought it out. And it is available, that address. Deliberately, I asked my people to put it on our website, where it is there, where I had brought out that what are the limitations and onus is on which agencies. So let me come to what I had said there. Now you see, what you raised is very correct. Now, the basic fundamental principles of radiation protection is, the first principle is the justification. Any activity which gives the radiation exposure must be justified. Then comes, once it is justified, then within that justified activity, there must be a optimization, that as low as reasonably achievable. And the third one is the dose limits. There are dose limits which are only for the occupational workers and the public, not for the patient. This is what I highlighted. Patient, there is no dose limit. It is purely, the onus is on to the physician, the person who is treating. He has the full ethical and professional responsibility to make sure that these basic fundamental principles of justification, optimization are appropriately followed. When it comes to the dose limits for the patients, that no regulator can put it, because it is the requirement of the therapeutic treatment or diagnostic requirement that what sort of radiation is to be given. So it is in the domain of this health authorities. They have to take up, and they should come out with the diagnostic reference level, which are matching with our dose constants in the parlance of occupational exposures. So this is to come out where we have said that, and we are interacting with them. Apart from telling there in official channel, also through that we are interacting with those authorities, but lukewarm response is there. We are trying that we must come out with some mechanism through which this dose to the patient should be regulated. At the same time, there should be some control over it, like as I said, the justification. If a diagnosis can be done through a non-radiation exposure mechanism, then that should be preferred first. If MRI can reveal you the thing, then you should not recommend for the CT. The CT requires much higher exposure. Now, problem is here that legal part is, it is not with us. The patient safety is not with us, because it goes in the domain of physician who has to decide. Now, we cannot question his authority in that part. What we can do is, we are only offering that our expertise. That part we will share with you, help you in arriving at this diagnostic reference levels, so that comparison can be done. That one procedure, a CT, if suppose that exposure can be limited to a very low value, statistically we can find out these numbers that they must be having, but we cannot look into those. Our requirement is the equipments or the machinery for this medical treatment, they must be equipped with the devices to record the dose. So we look only that part, that those records are maintained, but whether they are okay or not, that is a difficult part for us. So this is the issue, but the equipment part we are taking care. Equipment, like when only those equipments are allowed to be imported or installed and operated, which are type approved from radiation safety part of view by AERB. While that industrial safety and other parts, ISO and BIS come into the picture. But radiation safety part, they are type approved by the AERB, then only they are allowed to be imported or installed and operated.
Thank you for
Thank you.
Yes, for elaborating.
Very
Mr. Shahi has a question, I think.
Yeah.
Yes.
No, I think I have an extension in this, because all this, this has been very extensive presentation, Mr. Shukla, for 1.5 hours. But this point which Mahajan has raised is the crux of the problem. Resistance in society in general is on the basis of perception about radiation. And that is not a perception. Radiation is a reality in the atomic power process. So therefore, limitation of Atomic Energy Regulatory Board, either on account of lack of institutional structure or lack of medical, ability or empowerment from medical point of view makes the whole safety regulation a little incomplete. In fact, I don't know why this question has not been raised in the past. On the regulatory board, we should have medical expert with this expertise. On the regulatory board, in your environment board or safety board, we should have some infrastructure. We should independently examine whether the radiation exposure as permitted. Firstly, there should be a permitted level of radiation exposure at the design stage and at the operational stage, and to give confidence to the employees and to others and to the society. An independent audit of this or independent inspection of, see, you are right, there have been no accident. Mahajan was right, there is no accident. Let's not, so Factory Act, Atomic Energy Safety Regulatory Board does not have to be, and you are right, does not have to be equated with normal factory. Here, the whole globe, whole world is concerned about radiation to the people who are working, radiation exposure and its consequences. And in case of some further exposure, some accident in the system, what happens to the nearby society, people. So I think from both these angles, according to me, this is inadequate. Either the same regulatory board is empowered in terms of facilities, in terms of institutional support, and in terms of members, member on the one or two member on the regulatory board, or another independent radiation regulatory board, radiation safety regulatory board. Another, because if we are thinking in terms of going from 7,000 megawatt to 50,000, 60,000, 75,000, and why not, then this is inadequate. This is completely inadequate. I, as a professional, I feel a little disturbed. What about the rest of the country?
Sir, I would respond. I think there is some misunderstanding. What I said, there is a difference. Occupational exposure, the people working in the nuclear plants or working in the medical field, anywhere, occupationally, if they are exposed, that is under the AERB, and we are taking care of that.
Yes.
That part we are taking care. Doctors, what radiation they get as a being a occupational exposure, we are taking care. That is not a problem. I think what question raised by Mahajan Sahab was with respect to the patient. Patient dose, how much dose is to be given? Because there is a two different thing. Occupational exposure is not for your benefit, while the dose is given to the patient for treating him. So there we cannot come and limits cannot be put. For occupational exposure, very well limits are there, those constraints are there, and those limits are there. Only for patient, there is no dose limit, because it is for the medical profession to decide. That is what, let me clarify. Workers and public, there are well-defined dose limits. There is no issue, and we are regulating. And with respect to the medical facilities and their equipments, we have the expert member in our board, Dr. Rath, that former AIMS person, oncologist, he is our board member. And in our committees, which look after the radiation facilities, there are professional doctors and oncologists on our team. That is not an issue. Issue is the regulation of the patient dose. All other part is taken care of. Occupational exposure is very well taken care by AERB. It is the dose to the patient, that is the whether it is okay or not, because we do not know it. Doctor only can decide that for this tumor what dose is to be given. AERB cannot decide, regulator cannot decide, because it is purely the health requirement. So that is the, I think, some disconnect.
I think you are saying
but you can oblige. You can oblige the corporation.
I think
there are two aspects of this. One is for the treatment of a patient for an ailment. So that has to be decided by the doctor. But there is another misuse of the nuclear energy for diagnostic purposes. That is also being, and the exposure is coming not only from the treatment, but also from the exposure for the diagnostic purposes. So there has to be some regulations for that also. Anyhow,
Correct.
it's been very interesting.
I think there are certain issues which will fall with Indian Medical Council, certain issues which will fall in AERB. So we are trying to see here, drive those areas which are under the jurisdiction of Indian Medical Council, or whatever the new name is now. So I think let us keep
Shukla Saab
ourselves to
ki
AERB.
presentation is interesting. You know, we thought of getting some clarification of the other issues.
So he has said that as far as type approval of equipment is concerned, that is done by AERB. But when it comes to dose for the patient and how the patient has to be handled, that has to be taken care by the doctor. So that we have to maintain this clear distinction. And I
Sir,
think,
can I ask a question, Grover sir?
yes, Mr. S.K. Mitra.
Sir, first thing is my personal regards to you, and I see Madam also sitting by your side. Very interesting lecture. Very interesting lecture. I have 2 points to submit. One is, after the passing of Disaster Management Act in 2005, there are 2-3 basic changes. One is, disaster management has now taken a proactive approach instead of pro-reactive approach. It was pro-reactive, now it has become proactive approach. And second thing is the international forum, that is the Sendai framework which has come. They are insisting for risk management and not in emergency management. So in the light of these 2 points, I request either you or Shukla ji, who is Chairman AERB, to just say how it can be on a handshake basis, that now we are more proactive, not reactive, and now we are into more risk management and not emergency management.
I think we are always like that. Shukla ji, I think you can
Sir,
elaborate.
I think you have said it. I first disagree that we have changed this now. We have been from the day one, and that's why I started with the evolution. My own presentation, you see, 2 parts were there. That risk to be lower, the events which have the higher frequency, they should have this type of concept. This is what the risk management. We are from the day one working on the risk management, and we have been proactive on the disaster management. And that's why that our emergency preparedness response code, which has come taking into account of multiple agencies within the India, including NDMA, we had divided it very clearly in the 2 parts. The first part where that the decision, what is to be done. That's why I always say that understand control and safety, 2 different things. So here it was the safety part, which should be taken care by the plant. They know the plant condition. They should only pass on the information to the district administration what is to be done. They should not try to explain them Becquerel, millisievert and all those things, and should not confuse them. And neither instruct them that what sort of arrangement they are supposed to make. These bureaucrats, they are very much capable of doing what is to be done. Only they should be told. So we segregated very clearly. Technical part should be of the preparedness should be taken care by the NPCIL plant. They should only tell in this particular sector, so many people are to be evacuated. You have this much time. Rest part will be done by the district magistrate or the district collector as part of their preparedness part. So part A and part B. Part B is prepared by district authorities in consultation with NDMA. Part A is, which AERB reviews, is purely technical part with respect to the safety. So well-defined emergency preparedness and response things are available. We have changed it drastically. That earlier, it was only for the namesake, for the scene. People were being evacuated during the emergency exercise. Rather than having a positive impact, it was having a negative impact. So we said, no, this is not correct. If you see, the COVID has demonstrated that the district authorities can enforce whatever is needed. Here it was not evacuation, but COVID wanted people to be kept inside the home. Successfully, they have done it. They have enforced it, and they could keep. So if needed, they will be able to evacuate also. Now, main important part was in the development of the emergency scenario, the initial phase is the most important phase. That is the, like for health, we say that golden hour or golden minutes. Similarly, it is with the emergency response. So how operator is competent to initially take the action, that was not getting checked in the emergency preparedness. We have started it by changing our requirement and exercise methodology. Now, earlier scenario used to be known, and it was only a just knowing things were being simply replicated. Nobody was applying mind. Now operator does not know the scenario. AERB gives 3 envelopes, sealed envelopes. First envelope he has to open, and now we see the response, how he responds to that given scenario. Then we escalate it by the second envelope he has to open, where it will escalate the conditions to next level. Their response is seen. Then the third level, which will open it to the offsite emergency conditions. So this is the basic change which has been made in emergency response, that it is now realistic that given the unknown scenario, how a competent operator really behaves, because that initial, yeah.
Okay, I think we have come to the end of the allocated time for this interaction session, but still, if any questions are there, we can take 1 or 2 more questions.
Sir, I just want to add one point over, sir.
Yes, Mishra ji.
If there is a sort of gap in the area of dose limitations for patients, because that goes in the outside the boundary of present regulatory mechanism, there is a similar gap for dose limits for the emergency responders that we have faced when I was in NDMA. That emergency responders, there is no strict dose limits. They go by the scene. Just to aid this information. Thank you very much.
Grover sir.
Yes, DP Mishra ji.
Yeah. I've got a funny question. The war that is going on in Ukraine and near the nuclear power reactor, and how AERB or International Atomic Energy is going to control that situation.
I think
this, I can respond it, because similar thing, IAE is wasting their time in doing these things, because war-like situation, nothing can be predicted. And as I said, that there are 2 pillars of the safety: rule-based, knowledge-based. Rule-based, where everything is anticipated, you can make it. In war, what you can anticipate? So what you can do? So there are a limit within which you can anticipate and work it out. So beyond that, it is very difficult. So war-like situation, if enemy will not tell you what he is going to do. So what way you will prepare? You will try to do something from here and there. So it is very difficult to prepare for such thing. And mostly AERB does not come into the picture. Here comes the national security. That's why if you see, our exclusion zone has 2 components. Not only from the safety requirement. So from safety requirement, I may need a very small exclusion zone, but security requirement may demand for a larger thing, because the tank movement, this movement, that movement, those things are not openly talked about. So it is the national security part that they have to take care that how to safeguard the nuclear plant from the attack of this war-like situation, from attack, how they should be safeguarding. Preparedness with respect to safety would be only if any of the safety function is getting jeopardized. There are multiple defense in depth layers provided.
So who will be responsible in handling the situation?
Within the plant, it is the plant authorities which will be responsible. And as I explained, I took longer time for explaining the defense in depth. That 3 fundamental safety functions, as long as you are able to keep reactor in shutdown state and continue to cool the core, there should not be any problem. So as long as they are able to maintain that part, they may not be able to operate the reactor and generate the power, but they can still maintain it safe. So if their power supply and their water supply, if those things are cut, then they cannot do anything. Safety person cannot do. So there comes the security requirements that they should prohibit that other party should not come and cut off the nuclear plant with respect to power supply and the water resources.
But
I
then
think-
what happened when IGCAR has that, what you called it?
Fast reactor. Mishra ji, I think it's time to close. Maybe you can come to ARB when you are in Mumbai only. So one can have and continue this discussion.
Sure.
I think
Very
this
nice.
has-
Thank you very much.
Yes.
Yeah, this has been an excellent lecture and we had very good interactive session. Now I think we proceed further with the program.
Yeah.
Maybe Mr. Shahi can add his remarks.
Can I request such a brilliant lecture can come in an article form, which can be published in our chemical magazine or this thing for the benefit of the people?
I think India Energy Forum puts all these lectures on the website.
They come on the YouTube.
YouTube
They
also.
come on the YouTube.
Yes.
I think we have succeeded in most of the cases. Even this we can do. I don't think there is anything secret that
No, nothing.
Mr. Shukla has said. So therefore, it will come in the YouTube. But let me make some closing points, and then this has been one of the very wonderful and very successful sessions. In fact, what IEF has organized in last many months. And also the participation quality-wise and quantity-wise, number-wise has been very extensive. We are much more educated on the subject than we were. And that was the idea, that this is one thing where people are sometimes, perception is, it is over-exaggerated. Like one question I asked, another question Mahajan asked on the issue of radiation as effective. And I complimented, and I have complimented in many places that we have had very successful track record of running all our reactors, all our plants very well. The number and capacity less is a different issue. So therefore, India has and credit goes to the institution like what Mr. Shukla chairs. The radiation aspect is an aspect which concerns the public, and many times it is over-exaggerated. So it might not be the basic responsibility of the regulatory board to do the dissemination, but at the same time, in our journey or in our mission to expand this capacity enormously, it will figure up here and there. It will figure up whether large capacity or small capacity. Therefore, the gaps in appreciation and gaps in understanding would be somebody's responsibility. It may be regulatory board, it may not be regulatory board, and that somebody's responsibility will be mostly on account of or on this radiation-related safety aspects. I mean, segregated from the point of attack, segregated from the point of view of sabotage, segregated from the point of view of somebody attacks and tries to damage. But in the normal course of operation, limits of radiation, that operationally we are controlling. And I'm sure the regulatory board must be ensuring that it is being done. Transparency on the data, transparency on technical audit of this, perhaps would enhance the level of confidence. Like in Pollution Control Board, we are trying to publish, this is the level, that is the level. So I think definitely that will enhance the level of confidence of people, that it is well within limits. Like the other day, Dr. Kakotkar in one of the programs, he said that when you go for test in the hospital, there sometimes on some equipment you get exposed where the radiation level is more than normally it is found in a well-run and well-maintained nuclear power station. This is a great information. It's a great information. I mean, that is what he said. So therefore, this type of ensuring this, not because we have shown that we are doing well, but public should accept that there are mechanisms to handle this. Medical people being a part of the regulatory board or institutions and the regulatory board to take care of normal operations and normal radiation that might be expected, as opposed to any defense-related matter. That's a different thing. That, of course, on which there is a gap in knowledge, gap in information. That information, if public come to know, NGOs come to know, it will help. Because this would be one of the responsibility of all of us to see that this expansion exercise goes on without problem, And this type of misunderstanding or misrepresentation or lack of appreciation of the correct position must be kept. So thank you, Shukla Saab. You have educated us considerably, and we are assured, we are very happy that we are doing well, and we are also hopeful that we will continue to struggle for expansion of this sector in a big way. Thank you very much.
Thank
you, Shahid Saab. Undoubtedly, it was very superb presentation of the topic by Shukla Saab. And I'll say equally superb was the discussion and the assurance which he could give to the participants. Sorry, Grover Saab, you want to say something?
I just want to add one remark in response to the question by GP Mishra, that with regard to security of nuclear power plants, we have a unique situation in South Asia. India and Pakistan have an agreement of non-attack of nuclear facilities, and every year on 1st of January, this lists which gives the latitude and longitudes of all plants is exchanged on a regular basis, and this has been going on for a long time. In recent meetings with other countries, many people were not aware of it. They were surprised that such a good practice should be replicated in all other places also. I think this will assure the Indian audience, at least in our region, we are taking care of this particular aspect. Thank you. Mahajan, you can continue.
I think
Thank you, Robert Saab.
Very ably handling of the aspects of safety. That prompts us to think whether we could, in case Shukla Saab agrees, we may have another session on the aspects of the regulations with respect to the medical diagnostics and medical treatment, though it does not come under the direct purview of India Energy Forum. But I can share that in some of the physical conferences which we have been having once in a year, earlier we had invited medical experts to cover that, but that was only one part of the session. Maybe we can have one complete session on that aspect also sometime later. I must compliment and thank Shukla Saab for a very, very elaborate and to the point presentation, and assuring all the participants that nuclear power generation is safe and regulation exists for ensuring that the safety aspects. Before I request our Secretary General Bhambani Saab to propose a vote of thanks, I would like to share that once in a year we have physical conferences on nuclear energy, and during the COVID period we started the webinar series because physical conferences were not possible, and last year we resumed that. This year again in the month of February we will be discussing various aspects of nuclear power generation, where all the possible technologies which are available and which are futuristic, they will be covered. We will be sharing with you the details and dates, etc., as and when they are finalized. Now, may I request our Secretary General Bhambani Saab, who has been a founder member of India Energy Forum and a very, very active person. Under his secretaryship, the interaction with the general public and the nuclear experts have increased with these webinars, and now we have started the physical seminars also. May I request Bhambani Saab to propose the vote of thanks.
Thank you, Mr. Mahajan. I think we had a very, 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 very fruitful discussions. We are extremely grateful to Dr. Shukla for sharing the aspects of the safety of the nuclear stations, and I hope that India will achieve the power generation which is planned from nuclear so that we can have the carbon zero effect. I am also grateful to such a large participants who have participated. I think we are very, 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 very honored with their presence. I will just say a few words about the India Energy Forum. India Energy Forum is an NGO which was established in 2011. We have already completed 20 years. We are the only organization. We are only organization which is dealing with all verticals of energy. That is power generation, nuclear, renewables, from the beginning of its functioning. We have added the regulatory vertical also. And
as Mr. Mahajan said, the physical conference will be organized in February, most probably. We already had one where we had invited all the experts in this field. India is on the roadmap, on the path of its active participation. Many questions people ask that in the last 30, 40 years, the capacity generation has been low. Yes, it has been low because of various reasons, but now it is on the path and the 750 megawatt units are being planned. And I am hope that all the experts connected with the nuclear power will be satisfied with the growth and the aspects of this nuclear energy. I thank you very much again. I wish we had offered you the lunch, but it's a webinar. So we only say that bye-bye. Thank you very much. Have a nice day and enjoy your lunch. Thank you, Mr. Mahajan. Thank you, Dr. Grover. Thank you, Dr. Shukla, for very, 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 very effective webinar and the flagship webinar we have organized today. Thank you very much. Thank you. Thank you.
Mr. DP Mishra wanted to say something. Yeah, please go ahead.
Can you explain a little more on the India Energy Forum? Has it anything to do with atomic energy?
You see, India Energy Forum is a think tank of energy professionals, and it focuses on 7 verticals as explained by Bhambani Saab. Nuclear energy is one of these 7 verticals, and we are completely doing all these programs with full support and involvement of the Department of Atomic Energy.
And it is located in Bombay?
It is Delhi based.
Delhi based. Okay.
You are welcome to come and see and interact with our.
Yeah, I was the director of Tata Consulting Engineers.
Okay.
And so, Tata Consulting Engineers are onto energy. But I never had come across India Energy Forum.
So we can discuss offline whenever it is convenient to you.
Right, sir. Right.
Thank you, Vishnu.
Thanks.
Thank you very much. Thank you.
Okay, thank you.
All the participants. Thank you, all the participants. Thank you, Mr. Dr. Shukla. Again, I say thanks to all present today. Thank you.
Thank you, Shukla.